Hello, everyone. Welcome back once again. It is an absolute pleasure to have you here. Before we begin, remember where you are. This is the channel, The Next Engineering Framework. Today, we are going to do something special. We are going to deconstruct the mind of one of the most consequential figures of the modern semiconductor era. I am talking about Dr. Lisa Su, Chair and CEO of AMD. And we'll do this based on a deep personal conversation she had with Jody, a colleague from the industry. What we are going to see today isn't just a story of corporate success. It is a masterclass on how an engineer thinks when they have to make decisions that affect the entire planet. Lisa isn't just an executive. She is an MIT-trained electrical engineer who literally saved a historic company from irrelevance and positioned it as a fundamental pillar of the artificial intelligence era. So get comfortable, because we are going to break down how a technical leader is forged in the real world. First off, we need to understand identity. Who is Lisa really when the spotlights are off? When asked how she would introduce herself without mentioning her title at AMD, her answer is immediate and revealing. I am an engineer. And this is crucial. She says that on immigration forms in the occupation box, she always writes engineer. She doesn't write CEO, she doesn't write president. Her core is problem solving. Her story begins like that of many immigrants. She arrived in the United States at 3 years old, accompanying her father, who was going to graduate school. And here we see the first seed, the work ethic. Her parents had that mindset that being in the U.S. was the big opportunity, and the expectation was clear. You had to be excellent in math and science. But what's interesting isn't just the academic pressure, but the genuine curiosity. Lisa tells a fantastic anecdote about her brother's remote-controlled car. One day, the car stopped working. For a little girl, that could have been the end of the toy. For her, it was the start of a career. She took it apart and discovered that a wire had come loose. Upon reconnecting it, the car worked. That moment, that aha moment of understanding that one can intervene in the physical world and fix it, is the pure essence of engineering. It is that curiosity to know how things work that defines her. And this leads us to her academic stage. Lisa went to the prestigious Bronx High School of Science and then to MIT. And here, I want you to pay close attention, because she breaks a myth. She openly confesses, I wasn't the smartest person in my class. She felt she couldn't solve math problems as fast as her classmates. But instead of sinking, that motivated her. Being surrounded by brilliant people was her fuel. There is a decisive moment in her training that I want to highlight. At MIT, she decided to look for a job. Not because she needed it to survive, but because of that culture of effort. She got a position in a semiconductor lab in Hank Smith's lab. And do you know what she did? She wasn't designing the next revolutionary processor. She was, in her own words, the grunt work person for the graduate students. She made about $4 an hour, and her job consisted of putting 2-inch silicon wafers into a reactive ion etching machine, pressing a button, and waiting an hour. It might sound boring, but for her, it was magic. She would put those wafers under the microscope and see the tiny lines. There, in that repetitive and humble work, she fell in love with semiconductors. She realized that she preferred being in a lab doing physical things rather than sitting alone in front of a computer programming. She discovered that although she might not have been the best textbook student with perfect grades, if you put her in a team with a practical goal, she was unstoppable. Secondly, let's analyze the leap to leadership and making difficult decisions. Lisa spent much of her early career at IBM, where she learned to be a manager and technology leader. But there was a moment when she felt she had to leave. Why? Because she wanted to be at the table where the big decisions are made. At IBM, the focus was systems and services, but she was, at heart, a semiconductor person. She went through Freescale and finally, in 2012, arrived at AMD. And here is where the story gets tense. When Lisa gets the call in 2014 to be the CEO, AMD was not doing well. In fact, the company was in a very fragile situation. There is a concept in leadership research called the glass cliff. This term refers to the phenomenon where women are often promoted to key leadership positions precisely when a company is in crisis, which often sets them up for failure because the situation is almost insalvageable. When Jody, the interviewer, asks her about this, Lisa's response is fascinating in its pragmatism. She says, "Honestly, I didn't know what that glass cliff thing was." She didn't see a trap. She saw an opportunity. She saw AMD as a great company with a heritage of high performance that simply hadn't executed its plans well. For her, it was her dream job. She was trained for this. But the reality was harsh. When she took the helm, AMD had approximately 10% market share in servers, and she had to make a brutal decision. She realized that the technology they were developing wasn't competitive. If they continued down that path, they would slowly lose. So she decided to start from scratch. She had to tell her board of directors that they needed to stop and redesign, which meant their market share would drop before it went up. And so it did. They went from 10% to 1% market share. Imagine the pressure, leading a tech company and watching your market presence almost disappear because you're betting everything on a future design. She told them, "This will take 3 product generations and 5 years." And she delivered. Today, they have surpassed 40% in some metrics. That ability to have a long-term vision and withstand short-term pressure is what distinguishes a manager from a visionary.
Thanks a lot for watching the video. Please subscribe to help us create more content like this. Over to Charlie.
This brings us to a critical technical decision that defines modern computing. Lisa mentions that one of the hardest decisions was abandoning the traditional way of making chips. Until that moment, the norm was to make the chip bigger and monolithic. But she and her team, including technical geniuses like Mark Papermaster, decided to bet on chiplets. Allow me to use an analogy here so you can visualize the magnitude of this decision. Imagine you were trying to build the perfect city. The traditional method was trying to carve the entire city, buildings, streets, parks, out of a single giant block of marble. If you made a mistake in a corner or the marble had a crack, you had to throw away the whole city and start over. It was incredibly expensive and difficult to scale. Lisa and her team decided to change the strategy. Instead of a giant block, they would use perfect modular bricks, the chiplets, to build the city. If a brick failed, you changed it, but you didn't throw away the whole city. Plus, you could combine bricks of different types. This decision, which today seems obvious, was risky at the time because no one else was doing it that way. They asked themselves, are we bifurcating our path from the rest of the industry? Is this the right move? History has proven that it was. Thirdly, let's talk about the human factor: failure, imposter syndrome, and learning. Jody asks her directly about imposter syndrome, and Lisa, with refreshing honesty, admits that while she feels confident, it wasn't pleasant to hear so many people questioning whether AMD would survive in the beginning. But her advice for dealing with doubt is pure gold for us. She says she learned much more from her mistakes than from her successes. She vividly remembers the first project she ruined, the first financial quarter she missed, or that time she said something inappropriate on an earnings call. Those moments stick with you. And her advice is, it's okay to remember those moments, but you have to learn from them. Life is about continuous learning. No one is perfect. You just need to make more right decisions than wrong ones. For her, confidence is built on the experience of having survived failures. Now she says, there's nothing they can do to me because I've already been through it all. It is a resilience forged in the fire of experience. And she highlights something vital. Leadership can be lonely, but you shouldn't let it be. She fights that loneliness by talking to experts, to the engineers who are in the labs bringing systems to life. She looks for those who tell her the truth, breaking the echo chamber that usually surrounds CEOs. And we arrive at the fourth key point: the future. Artificial intelligence and the impact on humanity. Lisa Su has been named Person of the Year by Time magazine twice consecutively, once individually and once as part of a group of AI architects. She recognizes that we are at an inflection point. The year 2025 was the year people really started to understand the impact of AI. But what really excites her? It's not just processor speed, it's the intersection of technology and health. And here she shares a very personal story about her mother. Her mother, who was her great inspiration and who even started her own import-export business without knowing English well at first, became seriously ill. She spent 60 days in the intensive care unit. Although the doctors were excellent, Lisa noticed that the healthcare system was imperfect. Information was fragmented. The heart specialist didn't have data integrated with the kidney specialist. They treated them as parts, not as a whole human being. Lisa sees AI as the tool to fix this. She imagines a medicine that is much more predictive, preventive, and personalized. If AI can integrate all that data and help doctors see the whole, we can substantially improve the quality of life. That is the kind of problem an engineer wants to solve. It's not just silicon, it's human life. Furthermore, Lisa now feels the responsibility of being a role model. At first, it bothered her a bit to be labeled as a woman CEO or Asian American leader. She wanted to be known simply as a great CEO. But she has changed her mind. Now she sees it as a privilege. If her story can inspire others, it is worth it. She tells us how, after an engagement with the White House on AI education, they organized a hackathon. 15,000 high school students participated. And do you know who won? A team of 3 high school girls who learned to code AI in a weekend. That, for her, is true success. Seeing how the platform they have built inspires the next generation. To conclude, friends, Lisa Su's story teaches us that the path to engineering leadership is not a straight line of academic successes. It's a mixture of childhood curiosity, like fixing a toy car, of humility to do the dirty work in a lab, and of courage to make decisions that go against the current, like betting on Chiplets or restarting a company from scratch. Lisa shows us that leaders aren't born, they're made. They're made by studying, listening to experts, learning from colossal mistakes, and always keeping the focus on how technology can improve people's real lives. On this channel, the Next Engineering Framework, we are convinced that you are the ones who will build the solutions tomorrow. AI is the tool, but your judgment and your resilience will be the engine. And now I throw the question to you. After hearing how Lisa Su turned potential failure into resounding success thanks to a risky technical bet, what do you think is the glass cliff or the biggest technical challenge engineering faces today with the arrival of AI? Do you think more technical leadership is needed in the upper echelons of companies? Leave me your comments below. I would love to read them and debate with you. If you want more deep analyses of leaders who are changing the world, let me know. I am your trusted guide, and I'll see you in the next video to continue building the future. Until next time.